Navigating a commercial vessel down a waterway like the Mississippi River means fighting unpredictable currents, hidden shoals, and dense fog. Right now, moving thousands of tons of steel through these chaotic conditions relies almost entirely on the physical intuition of a human captain. This chart highlights the primary causes of maritime accidents. The towering segment you see here represents human error. Mistakes, fatigue, and misjudgments account for 75 to 96% of all incidents at sea. This reliance on human interpretation makes global shipping surprisingly reactive. Today, ships often arrive at port mouths and wait for days for a pilot, or travel hundreds of miles upriver only to turn back because conditions changed. In many sectors, a ship performs a productive task only 50% of its life, spending the rest idling and burning cheap, high-sulfur fuels. To expand these fleets, companies must find and train specialized crews, a process that takes years of apprenticeship to master the thousands of turns in a single river system. This creates a workforce shortage that prevents operators from scaling their businesses to meet global demand. When ships spend half their operational lives waiting for human shift changes or favorable weather windows, the logistical chain slows down. Overcoming these physical delays and transitioning to cleaner fuels requires a navigation system that can operate outside the limits of human senses. To solve this, engineers are developing maritime autonomous surface ships, crewless vessels controlled by artificial intelligence. Companies like Mythos AI are leading this transition with their advanced pilot assist system, which replaces human eyes and ears with a dense array of cameras, radar, and thermal sensors. Traditional marine electronics display raw data for a captain to interpret. This system actively learns the unique physics of the ship it's installed on. By measuring exactly how much rudder and propulsion is needed to counter a strong crosswind or a river eddy, the AI makes active, real-time decisions to keep the vessel on its planned path. This diagram outlines the International Maritime Organization's 4 specific degrees of automation. The scale starts at degree 1, where algorithms provide decision support to a human crew, and gradually removes humans from the loop as the technology scales. At degree 4, the ship's operating system gathers environmental data, determines a safe route, and executes maneuvers completely independently. By tracking how veteran captains handle extreme edge cases, this software captures decades of hard-earned maritime intuition and translates it into replicable code. Degree 4 autonomy is a functional reality. Mythos AI has logged over 11,000 miles of fully autonomous navigation, actively dodging heavy traffic and debris in some of North America's busiest commercial waterways. Without the need for shift changes or human sleeping quarters, an autonomous ship can stay in constant motion. Because the ships are moving cargo efficiently enough to eliminate wasted downtime, the transition to expensive, zero-emission fuels becomes economically viable for the first time. Removing the human crew also neutralizes maritime piracy. Without a human-operated bridge to storm or crew members to hold for ransom, the financial incentive for hijacking a vessel vanishes. By replacing the human element with intelligent software, developers have addressed the maritime industry's primary physical dangers, operating costs, and environmental liabilities simultaneously. But to achieve that efficiency, you must take a multi-million-ton kinetic object and wire it directly to a digital network. We already know the stakes of connecting critical physical infrastructure to digital networks. In 2024, a cyber attack on a London hospital pathology system canceled thousands of appointments and led to a patient's death. Now, a new class of digital threat is emerging. Security experts are sounding alarms over a recently developed AI model known as Claude Mythos, which possesses superhuman cybersecurity hacking capabilities. This model recently discovered a 27-year-old vulnerability in the Linux kernel, the exact type of foundational operating system that secures computer networks worldwide. It can spot structural weaknesses in code faster than human engineers can patch them. The very digital brains required to keep ships from crashing into riverbanks are the exact mechanisms that make them a target for automated cyber attacks. 2 different kinds of artificial intelligence are locking into a collision course: the algorithms built to navigate the physical world and the algorithms built to remotely hijack it. If a malicious AI breaches a 60-meter cargo vessel, it only needs to subtly corrupt the sensor data. If the ship's computers are tricked into seeing a clear channel where a bridge pylon actually stands, the physical consequences are catastrophic. A single zero-day exploit deployed at scale could paralyze a fully automated global port, instantly freezing billions of dollars in international trade. The future of global logistics is an invisible, continuous arms race between the AI systems that move our physical world and the AI systems trying to break it.